And next up are questions 3 and 4 from the 9192 worksheet. So for problem 3, it says find a formula for the nth term of the sequence whose first few terms are -3 halves, -1/6, 1/12, 3/20, 5/30, so on and so forth. Okay, so this is essentially doing the reverse of what we've seen in some of the previous examples. We were given the formula of a sub n, and then we were writing out the first few terms. Well, here we're given the first few terms. Our job is to come up with an a sub n that describes them. Okay, so my recommendation here, given that these are fractions, is to look at, say, the numerators and denominators separately. Okay, and notice for the numerators, I go from -3 to -1 to 1 to 3 to 5. I'm going up by 2 as I move from term to term. Okay, so that's an observation that will be useful. What about the denominators? 2, 6, 12, 20, 30. This might be a little bit harder to see, but for example, I noticed that 6 is 2 times 3, and 12 is 3 times 4, 20 is 4 times 5, 30 is 5 times 6, and what is 2? Well, 2 is 1 times 2. All right, and so there appears to be a pattern there as well. All right, so now how do I use those two observations about the numerators and denominators together to write down a sub n? Well, for the numerators, again, we're going up by 2 as we move from term to term, so I'm going to need a 2n. And so what about the -5? Well, so if I plug in 1 for n, this is going to give me a 2, and I then would need to subtract 5, so this first numerator will come out to be a -3. See, when I plug in 2, I'm going to get 2 times 2 is 4, 4 minus 5 is -1. When I plug in 3, I'm going to get 6 minus 5 is 1, so on and so forth. All right, so that's the numerator. What about the denominators? Well, look at the relationship between the numbers we're multiplying and the index number. So 1 times 2 when the index number is 1. Well, this is really what? N times n plus 1. When n is 2, likewise, we have n times n plus 1, right? 2 times 3. When n is 3, 3 times 4, yeah, that's again n times n plus 1. And I see that pattern holds. Okay, so this is a formula for the nth term of this sequence, and that does it. All right, cool. So then how about the next question here, number 4? First couple terms are 3, -1, 1/3, -1/9, 27th, -1/81st, and so on and so forth. Part A, find the next two terms of the sequence. Well, here the key observation, which becomes, I think, a little more apparent if you look at term 3 and on, because I see all these powers of 3, right? 3, 9, 27. And I also see this sign alternation, is that what I'm really doing here is I'm multiplying by -1/3 repeatedly, right, to get from term to term. So to get to the next term, which would be a7, just take -1/81st and multiply that by -1/3. That's going to give you 1/243. To get the next term, a sub 8, that's going to be found by taking the 1/243, multiplying that by -1/3. So that's -1/729. All right, cool. For part B, find a recurrence relation that generates the sequence. Well, again, just going back to that observation that we're just repeatedly multiplying by -1/3, that can be expressed as follows. So to go from a sub n to the next term, a sub n plus 1, just multiply a sub n by -1/3. And the starting term, a1, is just equal to 3. Okay, so this recurrence relation, as we discussed in the last video, right, in question 2, this relation will generate these terms. Okay, now for part C, it says find an explicit formula for the general nth term of the sequence. And so for that, we just want a formula much like what we wrote down for question 3, where I can just plug in a value of n and it's just going to spit out the corresponding nth term, right? So going back again to this observation, we're just repeatedly multiplying by -1/3. Okay, I can write down the following, right? So a1 is 3, and then to get to a2, I just multiply that 3 by negative 1/3. Then to get to the next one, just multiply by negative 1/3 again. So I'm really going to get what? 3 times negative 1/3 squared. Then multiply by negative 1/3 again. So I get 3 times negative 1/3 cubed, and so on and so forth. So all these terms have the form 3 times negative 1/3 raised to a power. And notice that the exponent is always 1 less than the index number, right? So like when n is 5, the exponent is 4. When n is 6, the exponent is 5. Okay, so the explicit formula there for the nth term, a sub n is equal to 3 times negative 1/3 raised to the n minus first power. All right, well, that is going to do it. I'll see you in the next video. Thanks so much.